You've probably heard of the National Museum of African American History and Culture, which opened in Washington, D.C. this September. However, you may not know that the construction of this building was very complex due to the soil conditions at the site.
The geotechnical engineers on the project ran into a couple problems because of the crowded nature of the city and the extremely high water table due to the nearby Potomac River.
The location of the site presented some serious challenges for geotechnical engineers. While located on the National Mall, it is also situated above the Tiber tributary.
The building itself was located 70 feet below ground, and between 55 and 60 feet of the building was built below the water table. The challenge for this project was to complete construction without affecting the surrounding structures due to uplift pressures diverted from the building foundation. To accurately account for this problem, the geotechnical engineers conducted a variety of tests on the soil.
Both laboratory and in situ tests were implemented by the engineers to determine the soil's properties. In the field, they used a standard penetration test and a cone penetration test. The standard penetration tests are conducted by digging a variety of boreholes around the site. These tests also allow the engineers to retrieve a sample of the soil being analyzed. The cone penetration tests are implemented by pushing the cone instrument into the soil to measure the soil's resistance and retrieves continuous data, which is useful in the analysis of the soil.
The original ground level on this borehole log is represented by the red line. As you can see, several borehole logs are shown on one graph. The deepest borehole on this log is only about 30 meters, or about 98 feet underground. The shortest is about 15 meters, about 49 feet. Even in the shortest boreholes, one can see the large variety of soil types present by each different hatching within the borehole. This is only a sample of the borehole logs for this project. Because of the importance of the surrounding soils in the project foundation, many borehole studies were done.
In the laboratory, engineers used indexing tests such as the Atterberg limits and moisture content testing to determine other specific properties of the soils. All of the tests were used to plan how the design team could engineer the foundation to effectively overcome the problems associated with the high water table and the 55 to 60 foot deep layer of very permeable soil. This made building the foundation a daunting task.
A pile load test was conducted during the design phase of the project. This test applies heavy weights to a specific area to check the strength of the soil underneath. Again, typical lab tests such as Atterberg limits and moisture content testing were also performed. The results from these tests showed the soils at the foundation have a low liquid limit and are not very plastic.
A low liquid limit means the soil state changes very easily from plastic to liquid, which is not ideal soil to build a foundation on. To combat this problem, the engineers decided to design the building so the foundation would sit on the available rock and partially weathered rock layers. The upper soils on the southern portion of the site were not strong enough to support the building loads, so a deep foundation system for that area was created.
During the project, there were a couple of problems that arose unexpectedly. One such problem was that the excavation wall failed, which caused groundwater to spill into the site.
To fix this, the construction group, Smith Group JJR, switched to a bathtub concrete infill, as you can see here, to keep the water out of the site. The walls were as thick as 6 feet in some places, and grouting techniques were also utilized to keep the water away from the building.
In conclusion, geotechnical engineering has proven to be very important in the construction of buildings around the globe, especially ones with unique soil problems such as the National Museum of African American History and Culture. Geotechnical vantage points were crucial in the successful problem solving and completion of this project.